Hello and welcome to Maths with Jacob. This lesson will focus on differentiating the exponential function. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. A very special exponential function is represented by y equals e to the power of x. To differentiate the above exponential function, we have y dashed equals e to the power of x. It can be seen that the derivative of the above function is exactly the same as the original function itself. The value of e is a constant, it is an irrational number, and has the approximate value of 2.71828, and it continues on forever. The graph of y equals e to the x is sketched below. The x-axis is an asymptote, so it never hits the x-axis. It cuts the y-axis at 0, 1, which is there, and the point 1e lies on the graph. The general exponential function. Consider y equals e to the function x. dy dx is function dashed x, e to the function x. Let's look at some examples. Let's differentiate y equals e to the 2x. So dy dx is 2e to the 2x, because if function x is 2x, therefore function dashed x is 2, and there's e to the function x, which is e to the 2x. Differentiate y equals e to the 3x plus 2, and the answer is 3e to the 3x plus 2. Because when you differentiate the function here, you get 3, so that's why you have the 3 there. Consider the function y equals e to the x. Find the exact slope of the tangent to this curve at x equals 1. So y dashed equals e to the x. So if we substitute 1 into this, because that's how we find the gradient, that'll be e to the power of 1, which is e. So that's the gradient when x equals 1. Consider the function e to the x squared. Find the exact slope of the tangent to this curve at x equals 3. So y dashed is 2x e to the x squared. Therefore y dash 3 is 2 3s are 6. E to the 3 squared, which is e to the power of 9. So 6e to the 9 is the slope of the tangent. Consider y equals 2x e to the power of x. Find dy dx. We can see from the above function that we need to use the product rule. And we remember earlier, d dx of uv was u dv dx plus v du dx. That's the product rule. Here, if we let u equals 2x, so there's 2x, we'll let that equal u, and v will equal e to the x. Therefore, dy dx equals u dv dx plus v du dx. So if we take out the common term, which will be 2e to the x, see there's a 2 in each term and an e to the x in each term, we take that out and there is our answer in factorised form. Consider y equals e to the 3x plus 1 all over e to the x, so there's u and there's v. We can see that the quotient rule is needed, and if we remember from earlier videos, the quotient rule is d dx of u over v is v du dx minus u dv dx over v squared. So that gives us v du dx minus u dv dx all over v squared. Now if v is e to the x, therefore v squared is e to the 2x. So from the numerator we can take out e to the x, because you can see how it's common. See here, e to the x is there, and it's also there. So we take out that common term. So we're left with 3e to the x minus, inside these grouping symbols, e to the 3x plus 1. And e to the 2x remains in the denominator. When we have e to the x over e to the 2x, we can cancel, and that leaves e to the x in the denominator. And in the numerator we have 3e to the 3x minus e to the 3x minus 1. So there is the answer. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? Sideburns. That's a nice one, isn't it? And here are the answers to the quick quiz, and the video is at your disposal.